Hello and welcome. In this video, I decided to do a random video. And that is on the actual workings of how a computer works. Now, I know many of you just turn on a computer and just expect it to do its thing. However, knowing how a computer works kind of makes everything you fight with a computer seem absolutely childish. And this is the reason why you have famous laughable arguments such as using a disk insert place as a coffee cup holder, and you have maybe you should turn it off and turn it back on. Well, this is actually caused by irrational thinking that a computer has feelings and that it's capable of being a dick. Well, the way a computer works, let's break it down to its very core. Back when they had something called a switchboard, in order to get electricity, you had to direct the electrical waves. You actually had to have these giant devices that allowed you to switch the electricity path so that something could be done. And there were giant factories where this was hugely important. Well, on a motherboard, you have something called a transistor. This transistor is a little black square thing. And this transistor allows a very crucial thing to happen. Your computer has a big, thick cord that goes into a power box. And this transistor is made up of a switchboard. And a switchboard does one thing. It either provides a 0 or a 1. And the reason why you see binary everywhere is because we built technology on that binary system. And the binary system, 0 and 1, stands for off and on. And that's the purpose of a transistor. Now, a transistor is actually really small. We're talking about atoms and nano atoms, and we're talking about extremely small. So electricity goes through, and depending on your computer, because whenever you go into your operating system, you have either 4-bit, 8-bit, 16-bit, 32-bit, and 64-bit, and eventually we're going to get to 128-bit. And that's how many operations the operating system can actually do. And the reason why it's called the operating system is because it's the system in which operations take place. So what this 64 and 32 means is the binary system works like this. It goes 2, 4, 8, 16, 32, and 64, which means that's 5. That's 5 different types of computation it can do at one time. So in other words, what it's saying is it can do 5 different types of operations at the same time, which is why 64-bit is really impressive. So the entire system is built on this on and off switch. And when you have one transistor, you're able to do 5 combinations or 4 combinations. Well, here's the thing. Transistors are made up of a lot more than just that one pair. In fact, when I say 64-bit, we're talking about one code block. We're talking about 5 pairs of zeros and ones. And a computer reads that in a millisecond. So, whenever you have your motherboard going from on to off, you're doing it in a split second. It's faster than you can blink, it's so fast. And then you have the motherboard itself. And you have to remember, the entire system is built on this binary system. So you have a graphics card, you have a RAM, you have a CPU, you have SATA drive. All of it is built on binary, off and on. In fact, the hard disk is really interesting because the hard disk, and the reason why it's called a hard disk is because it's a hard disk of ones and zeros. Essentially, it has this nano-sized little pin that etches into the disk, and it sends electricity through that disk. And depending on the zeros and the ones that show up, that's what shows up in your computer. So in other words, say you have a Word file, that's a little patch of 0 and 1s that are smaller than maybe 2 atoms together. It's very tiny. And the only difference is that a hard disk can go very, very short distances compared to a transistor, because the hard disk is just being read. The transistor is actually doing the computational work, which basically means it's doing the operations. So the transistors all read the actual information off of the hard disk. Well, what's the point of a CPU if it's the transistors that's doing the work? Well, the transistors are what keep the electricity going through the machine. The CPU is the one that does the work. The CPU is the one that compiles it into machine code and then actually does the work. The transistor is what actually provides electricity to the machine and allows it to continuously run and work properly. So you have a sound card, you have a graphics card, and you have a RAM. What is the point of these? Well, the sound card, it depends on whether you have a 128 or a 512, or that small bit of number is actually very important, because as with the transistor, what that 128 bit means is that you can play 6 different frequencies at the same time. Or the 512 means you can play 8 different frequencies at the same time. And these frequencies make up a combination to play one tune. And the same thing is possible of a graphics card. A graphics card can have this type of combination with the pixels on the screen. And something that's extremely important whenever you play video games is the difference between a DPI and a P. DPI means digital pixel per inch. What that essentially translates to is the amount of digital pixels per inch. And this deals with the actual 3D, 2D world we're talking about here. So you have your basic TV screen. Say you have a single picture. That's 2D. That's one layer of pixels. Well, the second that you add some shadow to the background, the second that you have a Z-axis basically, is the second that it becomes from 2D to 3D. And what that does is it increases the number of pixels in digital depth by 2, by 3, by 4, depends on how deep your Z index is. And so whenever it says DPI on the mouse, it's talking about the actual 3D environment in which you're talking about. So the graphics card itself is a pixel compiler. Essentially, it's able to compile a certain amount of pixels in a certain amount of rotations. So, say I have a 512-bit 2 gigabyte graphics card. What that basically means is I have a graphics card that can handle up to 2 gigabytes worth of video information in 512 megabyte chunks. That's what that basically means. And there's something called CUDAs, or shadow clusters, that determine the depth of color that's possible. And the more video RAM that you have, the more likely that these CUDAs are going to be higher. Because the more video RAM that you have, the more actual space that you have in your system. So you have a transistor which pushes the electricity through the entire machine and allows communication between these devices. You have the processor which takes the operations and tells everybody else what to do. You have the video card which determines what type of video will go on the machine. And nearly everything has a VRAM nowadays, but there was a time when the machines actually didn't have VRAM. The day that it became a screen technology was the day that VRAM was created. And we've had different names for VRAM, but with the advent of gamer technology, VRAM has become the synonymous word. Essentially, back when the Mark I and the Mark II were a thing, back when we actually developed the term bug, you had to physically flip switches. And based on whether the light was on or off, it would do a calculation the way that it was set up. And these would be the computers that took up entire big rooms. And so you have this motherboard, which is an imprinted technology, and the little lines that you see are the pathways of information, and the motherboard itself uses transistors to pass information back and forth, but the transistors have to have something that can accept the electrical pulses. And this is where you see the little copper wires on the motherboard itself. So you have your CPU, and then you have your RAM. And your RAM, by the way, is what accesses the stuff on your hard drive. And the reason why you need RAM is because the RAM randomly accesses it. And actually, it's really interesting because you have your RAM, which is flash memory. It's temporary memory. And you have your hard copy memory, which is your hard drive. And essentially what happens here is your computer reads the hard drive, copies the ones and zeros, and puts it inside of the RAM. And that's how it accesses the RAM itself. And so now you have your CPU telling everybody what it needs to do and compiling the instructions for the actual operating system into machine language so that it can be done. And then you have the transistors that are passing information back and forth, and you have the hard drive, which has a hard copy of everything that you did on the computer. Then you have the RAM that's copying the information and providing it for the video RAM. And then you have the sound card that's taking any sounds that come in the form of ones and zeros and turning them into frequencies. And that's it. That's essentially it. I mean, there's the disk drive, which is an optical lens that looks at the information on the disk and sends it to the CPU, who sends it to the video card, and the RAM. Oh, excuse me. The optical lens sends it to the CPU, which sends it to the RAM so that it can be accessed by the video RAM. And that's how movies are played. That's just how it happens. And then you have your keyboard, which is really cool because it's kind of like a typewriter, but electronic. And what I mean by this is when you press a button on your keyboard, you're essentially pressing a transistor down and providing the electricity and sending that into the computer. So you have A, it's maybe 0101. I'm pulling that off of the top of my head, and it sends it through that little wire or wirelessly to the connector that's USB and sends that to the CPU. And that's how your keyboard interacts with your computer. And you kind of do the same thing with your mouse. The only difference is that your mouse has a certain set of coordinates, and depending on your DPI and the size of your screen, it mathematically judges where your mouse would technically be or where it was from the last time that it was moved. And that's it, really. That's pretty much how a computer works.